All right, great. So, yeah, thank you. So my name is Soichi Hayashi. I work at the Pestilli Lab at Indiana University in Bloomington. The project I've been working on is called BrainLife.io. It's an online platform for reproducible neuroscience. So the mission really is to help the brain scientists to accelerate the scientific discovery by automated data management, large-scale analysis, and visualization. So what we mean by that is basically creating this platform that basically allows you to register code and data. And most excitingly, we also allow the users to come in with their computing resources and be able to register your computing resources on the platform so that you can actually take the code and data you uploaded and make it sort of like computable right from the cloud computing environment. Our belief is that by combining all these three, sort of essence of neuro data computing, we can basically improve the computational reproducibility for neuroscientists. So I want to give you sort of like a quick walkthrough of our user interface from the one user point of view, and then talk about a little bit of sort of key concepts. So once you register, the first thing you want to do is to create a project. So project is where your data and analysis is all stored. So this is where you can set up your access policy. You can make it a public or private. You can decide who are going to be your collaborators. And once you have that, you can then upload your data. So for this example, I'm going to upload the diffusion data. So you select the data from your computer. So some metadata, and once it's uploaded, we can actually run the validation on the server side. So you can check to see if the v-vals are flipped or v-vals are actually properly oriented. So if you have a whole bunch of data, though, you probably don't want to do that through the web user interface. Instead, you can use a biz uploader command line interface. So this allows you to upload the whole data set with a single command from a computer. I think I'll skip that. And once you have the data, then next thing you can do is to create what we call the process. So process is basically similar to kind of IPython notebook. So where you can sort of stage the data, produce the data derivatives. And then once you have the data stage, you can start selecting application available through BrainLife. So in this example, I'm going to select the free surfer dphase and run the free surfer on Open Science Grid. And then so you can keep sort of composing your workflow on the fly. So you don't have to wait for the previous step to finish. Everything runs in parallel. You can set up a configuration. And then once you're running a job, you can actually look at all the intermediate outputs and check the log and see what's going on. And of course, when the job is finished, next thing you want to do is to start visualizing. So we have a whole bunch of visualizer available based on which data type that the output is generated. So this one, for example, is free surfer output, so you can launch the free view on the fly off of our GPU-enabled virtual machines. And we also have sort of like visualizer for particular apps as well, so you don't have to sort of like launch this kind of advanced user interface. So this one is the WebGL-based user interface. And then, of course, once you're happy with the way it looks, you can download. And you can also basically archive the result back to the permanent archive. So that's great to do sort of like one subject at a time processing. But a lot of times when you have a sort of pipeline that's working and now you want to sort of scale up to apply the same workflow across all the subjects. So we really focus on the big data. So we wanted to sort of create something more failure tolerant system. So we basically came up with this idea of setting up a pipeline rule. So this is very similar to sort of like stream data processing. So instead of like sort of imperatively telling what the system wants to do, you basically start by application that you want to run, but then basically create a filtering. So like, in this example, I'm going to run this particular app and all of the AB, I think it's a by 2, yeah, project. And basically sort of like set up the rule that applies across the entire set of subjects. So in this example, it's just launching a whole bunch of processes. But at the same time, you can sort of, check the individual jobs just as easily as, just running individual processes. So you can update the rules. So you want to, relax the subject filtering. You can do that on the fly. So I'm basically removing one of the digits out of the subject filtering. So now it's going to run on like hundreds of subjects. So you can see the system is basically automatically launching a whole bunch of jobs. So that's great. And once you have all the output generated, so next thing you can do is to basically create a single view of all of your data assets. So as a BrainLife user, you can actually go to BrainLife for your project and create this page where you can use this as a sort of publication for your data citation. So we issue DOI. It has a list of all the data sets we produced and data provenance and a list of applications that are used to generate the data sets. All right, so yeah, that was the quick overview for the user interface. So just a little bit on the apps. BrainLife app basically is any GitHub repository that you register on the BrainLife. This is very similar to Zenodo. The application itself could be any code, so it could be any sort of end-to-end scientific workflow. So it could be like a large pipeline like fMRI prep. But we really want it to be sort of modular, sort of like a specific component that the user can then take these components together and construct their own pipeline, so that they can sort of play with the different combination applications, replace one part of the workflow with the other application, whatever that fits their data and their needs. But then the issue is like how, when you split the workflow into multiple pieces, then the issue is how do you sort of like make sure that, first app and then second app can interoperate each other. So to do that, we basically introduced this, concept of data type. And this is not really like sort of top-down specification, but more of like each individual developer themselves basically come up with their own sort of like agreement between the two apps and say, hey, I'm outputting this kind of data type, and is this useful? And the other developers say, oh yes, this is really great, but I need you to change the file name to this, and that sort of things. And once they agree, they can actually come to BrainLife and register the data type. So you can really think of like the graph of all these applications that are connected through a list of data type. So a little bit on architecture. So there's nothing magical here. We basically have a collection of open source microservices. Most of these interfaces basically interact with what we call the warehouse service. These are the sort of blue box there. We also have this group of service called Amaretti. So this is responsible for interfacing with the actual computing resources, taking care of data transfer, things like that. So this architecture basically allows us to sort of like scale up. If there's one component that's like, really bogged down, then we can sort of instantiate multiple copies of it, or maybe replace one service. So yeah, I mean, I'm a software engineer, so this is what I'm really excited to talk about. But if you have questions, I'd like to talk to you about that later. So this is a reproducibility platform. So we wanted to make sure that when somebody runs something in BrainLife, you can reproduce the same result later on. So we ran a whole bunch of tests and experiments to basically prove that once you generate the data set in the BrainLife, later on you can sort of repeat the same run. But not only that, we wanted to sort of show that when one of the computing resource goes down or maybe replaced, we can still reproduce the same output regardless of is it running on Azure or the GCP? So basically the third one there, run 3, we run the exact same workflow, but we basically killed one of the free surfer run in the middle, and basically it got resubmitted on a different cluster. Then we compare basically all the 3 outputs. As you can see, we have pretty consistent result. The first one's network connectivity, and then the second one, it looks like just one tiny line, but it's actually, all 3 lines overlapped each other, so there's absolutely no difference. And the same thing was for the free surfer. So we were able to basically quantitatively and qualitatively say that we were able to reproduce the results. So this is the last slide. So so we've been really trying hard to incorporate all these different technologies and bigger community outside of our lab. So we're really excited that we recently worked with Open Neuro team to basically expose the Open Neuro data set directly through BrainLife. So now if you upload your data set on Open Neuro, there'll be a button that says Analyze on BrainLife.io. So you can click on that, and it basically takes you to the BrainLife and then do all the data processing you just saw on the BrainLife side. We also work with Boutique. So now if you have a data set, you can export the data provenance as a Boutique descriptor. So basically you can take the descriptor and then maybe run it on Clouder, or I'm hoping that I will be able to run it on CBrain in the future. And also I'm working with the Data Lab team to basically allow the BrainLife publication through Data Lab. And among many other projects that we work with. So that's pretty much it. So I'd like to say thank you to Franco for letting me work in his lab. I technically don't belong in that psychology department. I'm actually working for the different group, and he's kind enough to let me work as a part of the team. And also I'd like to thank the PhD students and the collaborators from different labs around the world who helped us build all of those 200 plus applications you just saw, and basically being a first users, early adopters, to help us get all the kinks out. And thank you for the time.